Hello, welcome back to our channel. I am Anisha, your maths faculty for class 12. We are doing chapter number 5, in which we are doing our exercise 5.1 of this chapter, continuity and differentiability. And we are almost come to an end of this exercise. And in this video, we will do the last question of this exercise, that is nothing but question number 34. Let's move ahead. So this is our question. In this question, we have to find all the point of discontinuities where our function is defined as. So our f of x function is defined as mod x minus mod x plus 1. Okay, now we have to find all point of discontinuities. Always write what is given to you, our given point. I'm not writing here, I'm just telling orally. So what is given? We are given with a function. What we have to do to find all the point of the discontinuities of this function. Now, as you can think like graphically, mod x. We all it's a very well known now that the mod x is a continuous function in its whole domain, that is nothing but whole R, and any mod x plus a is a continuous function on whole R. So by using algebra of continuity, we can directly say that my f of x is continuous at each and every point. Okay, so what algebra of continuity we're gonna use here is if my g of x and say f of let's say h of x be some functions, and we are given that they are continuous at x equals to a, then my g of x plus h of x is also continuous at x equals to a. We're going to use this algebra of continuity. Let's begin for that. So for that, what we have is our function is defined like this. Now suppose your take your g of x as mod x and your h of x as mod x mod x plus 1. Now as you can see, we know that mod x function is continuous in its whole domain, that is in whole R, and our h of x is also continuous at whole R. So let's if I don't want to explain it in detail, because you already know that we have did a lot of questions in this, but if you want me, I can explain you how you guys can do for. Okay, mod x is very easy. I will explain you for h of x. So first write the function h of x in more explicit form, that is when my x is less than or equals to 1. Okay, my x is less than or equals to minus 1, then our function is defined as minus of x plus 1, right? Okay, and when my x is greater than minus 1, then our function is defined as x plus 1. Now, as you can see, for x less than or strictly less than minus 1, the function is a polynomial which is continuous. You can easily solve it by using the limit definition also, find its limit and find its function value. They both will be same. Similarly, for x greater than minus 1, that is function is again a polynomial. This is also continuous. And for x equals to 1, as you can see, always a non-trivial part is always for where the function is splitting, that is for x equals to minus 1. As you can see, for the limit x tends to minus 1, our h of x is nothing but 0, and our function value, that is h of minus 1, is also 0. So it is also continuous at x equals to minus 1. So overall, our h of x function is continuous at a whole domain, that is R. So now we're going to use our algebra of continuity, that is take any real, say x is some c belongs to our real number, then our h of x, our g of x and h of x both are continuous at x equals to c. So this implies by algebra of limit, our g of x plus, sorry, here it is minus, g of x minus h of x is also continuous at x equals to c. That means my mod x minus mod x plus 1 is continuous at x equals to c. That means our f of x is continuous at x equals to c. Okay, and we have started with any arbitrary real number c, and we have come to the point that f is continuous at c. So therefore, our function f is continuous for each and every real number, that is every point in its domain. So therefore, there is no point of discontinuity. So what is the conclusion? If I try to write, our conclusion is f not have a point of discontinuity, or do not have a point of discontinuity. Then, okay, that's all for today's video. I hope you guys like this video. Please do the questions once by yourself because it's very helpful for you when you like practice the questions, because mathematics is a subject where you have to do the practice. Anyone can just teach you, but at the end you have to make a push by yourself. So do it the questions by yourself, and please like, share, and subscribe. And let's meet in the next video. In next video, we're gonna do exercise 5.1 or 5.2 of this chapter, and it is related to differentiability or differentiation. So please recall all the topics of the differentiability, or if you have any doubts you can like see my introduction video, and let's meet in the next video. Thank you.